Hello, today we are going to work on some past IB questions related to the moles concept and stoichiometry just to avoid some common errors. So the first question over here is which contains the greatest number of moles of oxygen atoms? And the four options are given to us. To calculate the number of moles of oxygen atoms, we need to check out the number of oxygen atoms present in each of the formula given to us. So if it is 0.05 moles of magnesium nitrate, then the number of moles of oxygen atoms is going to be multiplied by 3 times 2, which is a 6 over here. For this one, it will be 0.05 multiplied by the number of oxygen atoms are 2 times 2, which is 4. For this one, the number of moles of oxygen atoms will be 0.1 multiplied by just one atom. And for the last one, it's going to be 0.1 multiplied by 2 because it has 2 oxygen atoms. So for this one, it will be 0.3. For this one, it will be 0.2. Here, this will be equal to 0.1 and this will be equal to 0.2. So our greatest number of moles are there in option A. Now the next question is asking how many moles of magnesium hydroxide. So we are being asked the number of moles of magnesium hydroxide which are produced with 0.5 moles of ammonia. So the number of moles of ammonia given to us is 0.5. So we have to go by the stoichiometric ratio. Now, to figure out the number of moles of magnesium hydroxide, we can actually do this question two different ways. 0.5 moles of ammonia is given, and now because we need to get rid of the number of moles of ammonia, so we will say 2 moles of ammonia are produced with 3 moles of magnesium hydroxide. And when we solve this, ammonia and ammonia gets cancelled out. So we have 0.3 multiplied by 3 and divided by 2 moles of magnesium hydroxide. So this gives us 0.75 moles of magnesium hydroxide. So definitely our right option is option C. And if you don't want to get into this, what you can simply do is take the number of moles of what is given to you, divide by its own coefficient, which is 2, and multiply by the coefficient for which you need to find the number of moles. So multiply by 3, and it is still the same number. It's just a faster way of doing it. For this question, it's saying that 0.02 moles of zinc. So let us write the number of moles of zinc, which is 0.02, is added to 10 centimeter cube. So 10 centimeter cube is the volume, which we can easily convert into liters or decimeter cube by just dividing it by 1000. So that gives us 0.01 decimeter cube. And the concentration given to us is 1 mole per decimeter cube. And now we are being asked to calculate the number of moles of hydrogen. So this is basically what we have to calculate. Because we already have the number of moles of zinc, so let us figure out the number of moles of HCl. So the number of moles of HCl is equal to concentration times volume. So this is 0.01 multiplied by 1. So that gives us 0.01 moles. Now, because we have the moles of both the reactants with us, So we have to figure out the limiting reagent. Now to calculate the limiting reagent, you will take the number of moles of HCl and divide by its stoichiometric coefficient. So 0.01 divided by 2, and that gives us 0.005. And now you can compare these two numbers, 0.005 and 0.02. So from here we can see that this number is smaller. So HCl is the limiting reagent. And once we have the limiting reagent, we should be able to calculate the number of moles of hydrogen using the limiting reagent. Now you have to be careful that what we've done over here is to just find the limiting reagent. These are not the moles we are going to be using for our calculations. So what we are going to do is we'll say we've been given 0.01 moles of HCl, and because we need to get rid of the moles of HCl, so we would say 2 moles of HCl. It produces 1 mole of hydrogen, and this HCl moles get cancelled. So we have the number of moles of hydrogens as 0.01 multiplied by 1 divided by 2, which is equal to 0.005 mole of hydrogen. So our correct option is option A. Now in this specific question, 2.67 grams of lead 2 carbonate is decomposed by heating until constant mass. So the mass of lead carbonate is given to us. Let us write it down, 2.67 grams. And we are being asked about the final mass of the solid. There's only one solid in the product, so we have to get to the mass of this one. So for finding the mass of lead 2 oxide, we first have to find the number of moles of lead carbonate, lead 2 carbonate. We'll take the given mass 2.67 grams and divide it by the molar mass of lead carbonate. So the molar mass of lead is 207.2 plus carbon is 12.01 plus oxygen is 16 times 3, and this is grams per mole. So if we find the ratio over here for the mass and the molar mass, so if we try solving it, it will be 2.67 grams being divided by 267.21 grams per mole. So this will be approximately equal to 0.01 mole. Now we've got the mole of lead 2 carbonate, and because the ratio is 1:1, so the number of moles of lead oxide, lead 2 oxide, will also be equal to 0.01 moles. And now to figure out the mass of lead oxide, we will have to take the number of moles and multiply by the molar mass of lead oxide. So this is going to be equal to 0.01 multiplied by lead oxide will be 207.2 plus 16. So this is equal to 2.23 grams. So the correct option for this question is option B. For this next one, the question says 16 grams of bromine. So bromine will be written as Br2 just because it is a diatomic element, plus it reacts with a metal and it forms MbR2. This compound is given to us and it is a balanced chemical equation. So the mass of bromine given to us is 16 grams and the mass of the metal given to us is 5.2 grams. and we are being asked to calculate the relative atomic mass of the metal. Now first, from here we'll calculate the number of moles of bromine. So the number of moles of Br2 will be equal to the given mass divided by its molar mass. For finding the molar mass of Br2, we'll have to take this atomic mass of bromine, which is 80, and multiply it by a 2. This gives us 0.1 mole, because in the balanced chemical equation, the ratio is 1:1. So the number of moles of the metal also is 0.1 moles. And now to figure out the molar mass, we know that the number of moles is equal to given mass divided by molar mass. So the molar mass will be equal to given mass divided by the number of moles. So given mass is 5.2 grams, and when we divide it by the molar mass, this is 0.1 mole. So 5.2 divided by 0.1, it should give us 52. So the right option is option C. The question here says how many moles of FeS2 are required. So we have to figure out the number of moles of this to produce 32 grams of SO2. So the mass of sulfur dioxide is given to us as 32 grams. Now to do this question from the mass of sulfur dioxide, we'll figure out the molar mass. So the number of moles is equal to the given mass divided by molar mass. The given mass is 32 grams, and the molar mass, for calculating that they have given us the relative atomic masses of sulfur and oxygen. So it will be sulfur is 32 plus 16 times 2 grams per mole. So this will give us 0.5 moles. As we have been able to calculate the number of moles of sulfur dioxide given to us, now to figure out the number of moles of FeS2, we'll take the shortcut again as used in the previous question. So we'll take this 0.5 moles of SO2, divide by its own coefficient, divided by an 8, and now being multiplied by the coefficient of FeS2, for which we have to find the number of moles. So this is going to be multiplied by 4, and once we solve it, the number of moles of FeS2, we can get it as 0.25. So the right answer to this question is option A. For this next question, 0.2 moles of sodium hydrogen carbonate. So the number of moles of sodium hydrogen carbonate is 0.2 moles, and it is decomposed by heating until constant mass. How many moles of the gas are produced? So now you have to be careful that here two gases are being produced. One is water vapor and the other is carbon dioxide. So we'll have to figure out the number of moles of both of them and add them together to get the total number of moles of the gases produced. So we know that to get to the number of moles of water, we'll take 0.2, which is the moles of sodium hydrogen carbonate, and divide by its own coefficient. So divide by 2 and multiply it by the coefficient of the water, which is 1. So this gives us 0.1 moles of water. And now to figure out the number of moles of carbon dioxide, exactly the same process. The number of moles of sodium hydrogen carbonate are 0.2. Divide by its own coefficient, which is 2, and multiplied by the coefficient of the substance for which you're trying to figure out the moles. So that's like 1 mole of carbon dioxide. So this also gives us 0.1 moles. And now for the total number of moles, it's going to be 0.1 plus 0.1, which is 0.2 moles of the gas are produced. So the right option is option B. Okay, the next question. 3 moles of C3H8. So we've been given the number of moles of C3H8, which is 3 moles, and it is mixed with 20 moles of oxygen. So number of moles of oxygen are 20 moles, and we have to quantify the substance which is present at the end of the reaction. So the substance which is going to be present at the end of the reaction is the excess reagent, because the limiting reagent is going to be used up completely. So for doing this question, we'll first figure out the limiting reagent. So for that, what we are going to do is we'll take the moles of oxygen, which is 20, and divide by its own coefficient, which is just 5. So this gives us the number 4. And now we can compare these two moles. 3 and 4, when you compare, you can clearly see that 3 is a lower value, and we haven't divided or done anything to it because its coefficient is just 1. So I've let it be the same. When we do the comparison, 3 is a smaller number, so definitely this is the limiting reagent. Now we just need to figure out this limiting reagent is going to use up how much of oxygen. So for that, the number of oxygen which needs to be used up to react with C3H8 will be 3 divided by its own coefficient, which is 1, multiplied by the coefficient of oxygen, which is 5. So which means this is 15 moles of oxygen are going to be used up. The number of moles of oxygen given are 20 moles, out of which 15 are used up. So the number of moles of oxygen which are left unreacted is equal to 20 minus 15, which is 5 moles, and this is for oxygen. So our right option is 5 moles of oxygen, which is option B. For the next one, it says, what is the number of hydrogen atoms? Now we have to be careful. They're not asking how many moles of hydrogen atoms. It is the number of hydrogen atoms. So the compound given to us is calcium hydrogen carbonate. And if we have 2 moles of calcium hydrogen carbonate, so to figure out the number of molecules, we'll take the number of moles and multiply it by the Avogadro's constant, which is 6.02 times 10 to the power of 23. So the number of moles are 2 moles and multiplied by 6.02 times 10 to the power of 23 per moles. So now we have 1.204 multiplied by 10 to the power 24 molecules. And why are we saying molecules? Just because it's like a compound given to us, because we have to find the number of hydrogen atoms. So one molecule has got 2 hydrogen atoms. So what we are going to do is we are going to take the number of molecules we have found and multiply that number by 2, because each molecule has 2 hydrogen atoms, to get the total number of hydrogen atoms. And this gives us 2.41 times 10 to the power of 24 atoms of hydrogen. So the right option is option D, Now this question could be done one more way. So when we've been given the number of moles, so we would say 2 moles of calcium hydrogen carbonate. So we want to get rid of the moles, so we will write 1 mole of calcium hydrogen carbonate has 6.02 times 10 to the power of 23 molecules. And then because we want to get rid of the molecules, so we would say that 1 molecule of calcium hydrogen carbonate has 2 hydrogen atoms. So here moles and moles get cancelled, molecules and molecules gets cancelled. So you have 2 times 6.02 times 10 to the power of 23 times 2 and divided by 1. So these many hydrogen atoms we will get, which is the same. Only the process is different. Now for this question, it says, what is the value of X when 32.2 grams of sodium sulfate, a hydrate, we don't know how many molecules of water are present, so that's basically what we have to find. So we have Na2SO4 XH2O. The total mass of this is 32.2 grams, and when we heat it, we are left with 14.2 grams of anhydrous sodium sulfate. So Na2SO4, the mass of this is 14.2 grams. So which means the water which got evaporated, the mass of that is 32.2, subtract 14.2, which is 18 grams. Now, because we've got the mass of the anhydrous part and the water, so we can figure out the value of X. So we'll take Na2SO4 and H2O. So the mass of each one is 14.2 and this is 18. Now we'll get to the molar mass. So the molar mass of sodium sulfate when calculated is 142 grams per mole. Water is 1 times 2 plus 16, which is 18 grams per mole. Now we'll calculate the number of moles, which is the given mass divided by the molar mass. So 14.2 divided by 142 is 0.1 and 18 divided by 18 is going to be 1. Now to get to the simplest whole number ratio, we'll take both the moles and divide them by the smallest number of moles, which is 0.1. So to get the smallest whole number ratio, 0.1 divided by itself gives a 1 and 1 divided by 0.1 gives a 10. So the formula for this hydrate can be written as Na2SO4 with 10 water molecules. So 10 H2O. So the correct value of X for this question is 10, which is the option D. Now for the next question, it says how many atoms of nitrogen are there? Again, they're not asking you the moles of nitrogen atoms. They're asking you the number of atoms of nitrogen. And we've been given moles of ammonium carbonate. So we have 0.5 moles of NH4 whole twice CO3. And first we'll find the number of molecules. For that we need to get rid of the moles. So we know that 1 mole of ammonium carbonate has 6.02 times 10 to the power of 23 molecules of ammonium carbonate. And now to get to the atoms of nitrogen, so we can see over here one molecule has 2 atoms of nitrogen. So this 2 is applicable for whatever is written inside the bracket. So we will now write that one molecule, definitely for ammonium carbonate, has 2 nitrogen atoms. So here the moles and moles get cancelled, molecules and molecules get cancelled. So the number of nitrogen atoms are 0.5 multiplied by 6.02 times 10 to the power of 23 multiplied by 2. Denominator is just 1. We don't need to write. So these are the number of nitrogen atoms present in 0.5 moles. So here 0.5 times 2 is just 1. So the answer to this one is 6.02 times 10 to the power of 23 nitrogen atoms. So the correct option is option D. So the question here says, which solution neutralizes 50 centimeter cube of 0.120 moles per decimeter cube of NaOH? So for NaOH, we have been given the volume. So volume is 0.05 decimeter cube. So to change centimeter cube into decimeter cube, we have to divide it by 1,000. And the concentration is given as 0.120 moles per decimeter cube. So first what we need to do over here is figure out the number of moles. Number of moles is equal to concentration times volume. So this is 0.05 multiplied by 0.120. Here the decimeter cube will get cancelled and your answer will be left in moles. So this is equal to 6 times 10 to the power of -3 moles. Now what we have to be careful about is we have the number of moles of the base NaOH, and if we want this to be neutralized, the number of H positive ions, the number of moles of H positive ions need to be the same. So if we calculate the number of moles from this, it will be 0.05 multiplied by 0.06, which is 3 times 10 to the power of -3 moles. Now, if we multiply this concentration and volume, we get 3 times 10 to the power of -3, but the number of hydrogen ions produced to neutralize NaOH will be double. We can see clearly over here. So the H positive ions will be double of it, which is going to be 6 times 10 to the power of -3. If we figure out the number of moles over here, and moreover, this is a weak acid, so its Ka value should be known to get for the total neutralization. So here also the number of moles are 3 times 10 to the power of -3, and for this 0.0125 multiplied by 0.08. So you have to keep in mind that the volume always need to be divided by 1,000 to change centimeter cube into decimeter cube. So this gives us 1 times 10 to the power of -3, but each molecule gives out 3 atoms, so the number of moles of hydrogen ions is going to be multiplied by 3. So this is 3 times 10 to the power of -3. So now we can clearly see that the same number of moles are only being given by H2SO4, which is going to give exactly the same number of H positive ions as the number of OH negative ions by NaOH. So the right option is option C. For this specific question, it says which of these molecular formulae are also the empirical formulae. So the difference between the empirical and the molecular formula is the empirical formula is the simplest whole number ratio of the atoms, and the molecular formula is the exact formula. So this one, if it is a molecular formula, its empirical formula is going to be the same because it's already reduced. 2:6:1 cannot be reduced further. These, all the number of atoms can be divided by a 2. So this molecular formula will give a different empirical formula, which is CH2O. And again, this molecular formula, the 5 and the 12, they do not have any common factor. So the empirical formula is going to remain the same. So our correct option for this question is option B. The next question says, what is the molar mass in grams per mole? So we have to figure out the molar mass of a compound if 0.2 moles. So the number of moles given to us are 0.2 moles, and it has a mass. The given mass is 13.2 grams. So we know that the number of moles is equal to the given mass divided by molar mass. So which means if we have to figure out the molar mass, it needs to be the given mass divided by the number of moles. The given mass is 13.2 grams. The number of moles are 0.2 moles. From here we get 66 grams per mole. So our correct option is option B. This question says, what is the number of carbon atoms in 12 grams of ethanoic acid? So the mass of ethanoic acid is 12 grams, and to get rid of the grams, we need the molar mass, which is given to us. So we will say 60 grams is the mass of 1 mole. Now, because we need to get rid of the moles, so we will say that 1 mole, and just because it's a compound, so it will have 6.02 times 10 to the power of 23 molecules. But we are not being asked molecules. We have to give the number of carbon atoms. So we would say 1 molecule of ethanoic acid has 2 carbon atoms. So 1 molecule has 2 carbon atoms. So here grams and grams are gone, moles and moles are gone, molecules and molecules are gone. So we are left with 12 times 6.02 times 10 to the power of 23 multiplied by 2. So these all the numbers in multiplication, and divided by 60 carbon atoms. So for this we get 2.40 multiplied by 10 to the power of 23 carbon atoms. So our right option is option D. This next question says, how many moles of oxygen atoms are there in 0.5 moles of hydrated iron to ammonium sulfate? So the formula is given to us, and we've been given 0.5 moles of it. Now they're not asking you the number of atoms, they're asking you the moles of oxygen atoms. So these are the moles of the hydrated salt. So we would say that 1 mole of hydrated salt has how many oxygen atoms? So if you check oxygen atoms, it's 4 times 2. So 8 over here plus 6 over here. So 8 plus 6 is 14. So 1 mole of the molecule has 14 moles of oxygen atoms. So this moles of the molecules get cancelled, and then we have 0.5 multiplied by 14 moles of oxygen atoms. So when this multiplied together gives you 7, and B is the right option. If you want more of these videos coming up, please like and subscribe to my channel. And also, if you want me to make the videos on some specific topics, please comment and I will try to do that. See you in the next one. Bye bye.